Part 284C3M1B7C8E13C9C6D3P38D19D7b33. Line 22f1fa19c3m1b7c8e13c9c6d 3p38d19d7b33 RF over glass, sputtering signals, UFO 5G Wow Seti. There's the alien radio signal, and this is about coatings for glass, PDF files, radio frequency sputter from WOW data communications device. So there's the line of data there, RF over glass transmission signals, UFO 5G Wow Seti. Okay, so that was the name of the video. So then the keyword I had was Fonnula particles plus wavelength formulas and Compton wavelength. So the keywords to Google was Fonnula units, time mole 1472. So this came up from Elsevier. Thin solid films, March 2009. So it's the 7th International Conference on Coatings on Glass and Particles, Advanced Coatings for a Large Area of High Volume Products. And it's radio frequency sputter deposition of high quality conductive and transparent ZNO:(AL) films on polymer substrates for thin film solar cell applications. And there's the name of the scientists that did it. And they are from Spain. And yeah, Spain. And there's the link to it, dx.doi.org. The abstract is thick aluminum doped zinc oxide films were deposited at substrate temperatures from 100 degrees Celsius to room temperature on polyethylene terephthalate by radio frequency magneton sputtering, varying the deposition parameters such as radio frequency, power, and working pressure. Structural, optical, and electrical properties were analyzed using an X-ray diffractometer, a spectrometer, and a 4-point probe, respectively. Films were polycrystalline, showing a strong preferred C-axis orientation. The best optical and electrical results were achieved using a substrate temperature of 100 degrees Celsius. Furthermore, high transmittance close to 80% in the visible wavelength range were obtained for those films deposited at the lowest argon pressure used of 0.2 Pa. In addition, resistivities as low as 1.1 times 10 minus to the power 3, and then upside down horseshoe thingy, cm were deposited at an RF power of 75 W. Finally, a comparison of the properties of the films deposited on polymer and glass substrates was performed, obtaining values of the figure of merit for the films on polymer comparable to those obtained on glass substrates, 17, 700, and those funny little symbols there. Okay, so the keywords are aluminum, zinc oxide, sputtering, flexible substrate, and solar cell. Figures and tables from the article A. So this is a normalized intensity ARB units, and it's got the words PET in the graph. And then it's got normalized intensity ARB units, and it's got the words PET in the graph. And it says figure 1 is the XRD diffraction patterns of the AZO film deposited at 75 W and 0.67 Pa 5 mTOR on the polymetric substrate at different temperatures from RT to 100 degrees. Then there's transmittance wavelength NMs and transmittance percentages wavelengths NMs, and then the optical figure 2 is the optical transmittance of AZO films deposited at A 75 W and 0.675 mTOR on PET at different substrate temperatures, and B 100 degrees Celsius and 0.2 Pa 1.5 mTOR on PET at different RF powers. And then there's resistivity RF power, and then there's a resistivity RF power W. A and B results from figure 3, dependence of electrical properties of AZO films with RF power at different A substrate temperatures and B working pressures. So A is the temperatures and B is the working pressures. So the third one, figure 4, is a diffraction is normalized intensity at 20 degrees. So figure 4 is XRD diffraction patterns of the AZO films deposited on glass and PT at 100 degrees Celsius under optimized sputtering conditions, respectively. So we were talking about diffracting a laser signal onto different crystals and stuff within the core of the UFO spaceship. So this actually pertains to it, and it's showing results of some test or something that somebody did. And this is showing normalized transmission, and it gives you the wavelength in nms, AZO-PET/PET, and AZO/glass. So you can see they're pretty similar to one another. Can't tell which one's bigger. So figure 5, normalized transmission spectra of AZO films deposited on glass substrate, white square, and on PET substrate, black line. So we're talking about using obsidian glass and mirrors and lasers in the actual makeup of this communication signal device. So this is quite interesting because it brought up the glass issue and it brought up the lasers and the diffraction, so I thought it was kind of cool that it came up. So it's right along the same lines of what we're trying to develop here. So this is the working pressure PA, AZO/glass and AZO/PET at 100 degrees Celsius, and one's at 175 west and the other's at 75 west. Okay, sorry. It says W and I'm assuming it's west, but it's probably wrong. So I apologize if I'm getting that wrong. Figure 6, figure of merit of the AZO film. I'm so used to doing weather stuff, you know, or southeast west, so that's why it just pops out automatically. So figure 6, figure of merit of the AZO films deposit on PET, white squares, and on glass, black squares, with the working pressure. The substrate temperature was kept constant at 100 degrees Celsius, and the RF power was 75 W and 175 W. I wonder if that's the watts. For the AZO film deposited on the polymer and glass, respectively. So that's from www.sciencedirect.com. There's a link there, and that'll go up with the video as well. So the keyword Fonnula units, tile moles, 1472 will continue in our next video. Thank you for watching.